Hello sir, my name is Raybert James M. Tolero, 4th year Section B. My topic is all about normal stress. Normal stress or stress is defined as the strength of material per unit area or unit strength. It is the force on a member divided by area which carries the force formerly expressed in psi, now in Newton per mm squared or MPa. So we have the formula where P is the applied normal load in Newton and A is the area in mm squared. The maximum stress in tension or compression occurs over a section normal to the load. As you can see in the figure, we have two classification of stress. We have the bar in tension and the bar in compression. As you can see, if the bar is in tension, both the forces are going away from each other, while compression is both forces are going towards each other. So now, let's try to answer some example problems. So we have here example 1. A hollow steel tube with an inside diameter of 100 millimeter must carry a tensile load of 400 kilonewton. Determine the outside diameter of the tube if the stress is limited to 120 meganewtons per meter squared. So, as you can see in the figure, we have there the downforce of 400 kilonewtons and the small diameter of 100, and we have to find the bigger diameter, which is D. So solution, we have here P is equals to stress times area, where P is equals to 400 kilonewton or equals to 400,000 newton. Then we have here stress is equals to 120 MPa. Then we find the area of the hollow tube, which is 1/4 pi d squared minus 1/4 pi small d squared. 1/4 pi d squared minus 1/4 pi 100 squared. Then you have here 1/4 pi d squared minus 10,000. Then here, thus 400,000, which is the area, is equals to 120 1/4 pi d squared minus 10,000. 400,000 is equals to 30 pi d squared minus 300,000 pi. So we can know now that d squared is equals to 400,000 plus 300,000 pi all over 30 pi. Then D is equals to 119.35 mm. That's the answer. Then we have here our second problem. A homogeneous 800 kilogram bar AB is supported at either end by a cable as shown in the figure. Calculate the smallest area of each cable if the stress is not to exceed 90 MPa in bronze and 120 MPa in steel. So here, as you can see at the figure, I think the figure is slightly off or wrong because at the problem it is indicated that the cables are at the end of the bar. So we'll just assume that the cables are at the end of the bar. So first, I think we need to make the free body diagram before we can proceed and tackle this problem. So here we make the FBD or free body diagram. First, we have to make the bar and add both forces going upward and the weight at the middle going downwards. Okay, we have to put the necessary values or measurements of each forces. Okay, now we can proceed for the solution. So here we'll go by symmetry, so meaning both are equal, same sides, right? So PBR or P bronze is equals to P steel. So we have 1 half times 7848 is equals to 3924. So we get the half because the forces of the weight is um, at the middle part. For bronze cable, we have to use the formula of the stress. So we have PBR is equals to stress BR times area BR, which is equals to 3924 equals 90 ABR, area BR. And we have the answer of the area of the bronze, which is equals to 43.6 millimeter squared. And here for the steel cable, so P steel is equals to stress steel times area steel. So 3924 is equals to 120 area steel. So divide, we have area steel is equals to 32.7 mm squared or 32.7 mm squared. So we have here the answers for the area BR and area steel. And that concludes my discussion about normal stress. So both my examples are only very simple and easy to understand, but stress is a very broad and has a long process, especially if the members are connected together. For example, the truss in roof truss and bridges. So thank you and God bless Sir Bacchus.